Hi everyone and welcome back. Let's do the part 2 of the previous video. And I also want to talk about, okay, this is the playlist which we are covering. It has lots of videos, so don't get confused. If you are just checking these videos out in order, there would be no any issue. These are perfectly aligned and in a perfect order. So we are covering just the last few set of videos where we are covering TCP based, Kafka or RabbitMQ based microservices in the Nestjs. Then we can wrap up this particular playlist because we will be done with the overall the microservice concepts, microservices, how we are building it, how all these things are happening. Then we can focus more on the other playlist. Coming to this, we were talking about this architecture from the previous video, and now we are going to build these TCP based microservices. We will see how they looks like, what is the difference between creating a simple REST based service and a TCP or a simple NestJs microservice. Till now, most of my video sessions or trainings, I covered only the REST based Nestjs microservice. But what if you want to create a TCP based or RabbitMQ, Kafka or EMQP based microservice, which is a lightweight? Here we have two TCP based services, user service and auth service. And if you look into the main.ts, here you will see the big difference. Here, what are the other options? Create application context, create microservice. In default, we create application context. But if here we are using NestJs microservices, so we are calling create microservice. And then create microservice, the root module and the other options are transport and the options. Transport, what all transport it supports, like you can pass GRPC, Kafka and all. If you are using GRPC, then you have to also specify the proto files and you have to write a GRPC methods. MQTT, Kafka, Redis, RMQ, here we are talking about TCP. And this is the options, this is the host and port for your TCP microservice. So the client would know, okay, this is the host, this is the port and this is the transport. I can connect to that TCP service running somewhere. Okay, rest all the things are same. The user module, here we have a user entity. I mean, it's the whole Nestjs structure we create. You import all the modules, database module, type-orm module, JWT, Nestjs JWT module, and then user controller and user service. Inside controller, it's not going to have the default methods of the REST APIs. Like controller is, we were also creating controller there. Here also we see the controller, but the difference is we are not writing @get, @put, @post and patch, all these methods. Here we are using message pattern and the event pattern. Message pattern, when you are requesting a response back from the caller, whoever is calling it. So these are the different actions it is supporting. And TCP client can send these actions with the payload like search params, simple ID and user params. So another service is the token service. There also we are doing something similar. Here this is also using the transport. Here we do have a different port, because how we are getting these ports and all, we are using same config module everywhere, and we are having a local env.example, I mean the local env file in each and every service. And we are using this .env to populate this process, to populate this .env inside a process.env. So we get the host, port, database details and all, because we are using type-orm module that requires a database, and we have these two different database, token API database and the user API database. And this is the port 3003 that is running on 3004, and gateway, here we need to specify the ports of both the services, 3003, 3004. This is the auth service, user service and the gateway. Now let's see a simple example, simple demo. Okay, here I'm able to log in. I can just, you can see we are getting a token. That's fine. Here I'm trying to get user by ID. I mean, it's just going to give you all the users. It's coming forbidden. Why that is coming? Because I added this user route as a protected route. So we'll go to our user service, our gateway, and this is our controller. Here let's see our first route, which is get user by token. So what it is expecting, okay, you should send authorization token, then only I will allow you to access this. So we have this authorized true. What this is doing is, this annotation is just putting the token, putting this secured true. This is like a metadata, and we are already registering this auth guard at the application level. So this is like app guard. In the app guard we have registered auth guard. You can see authorization guard. So this is registered at the app level, means all the routes will use it, but we are consuming it only where the secured is true. And how we are populating secured true? Through the controller. In the controller, if you are using this as a false, that means we are not using this auth guard if you are passing it true. So what this annotation is doing, it is populating this secured value flag, secured metadata as a true. If you pass false, it will set the secured metadata as a false. And then inside this auth guard, authorization guard, if the secured value which is coming, we are using reflector API to get what is the value of secured which you have set in the controller. If it is true, then we are good. If it is false, then we don't need to check or anything else. We will allow user to access. But if it is true, that means we need to check, are you sending me this authorization header? If yes, if no, first of all, the API is secured and you are not sending me this authorization header. I think we are not sending the authorization header here. That's why it's forbidden resource. We are sending a return false. Let's say you are sending it, but the token is not. You can also decode the token. Currently the syntax of the token I'm expecting is bearer and the token string. So I'm splitting it and I'm sending this token to the decode token action. So this is going to the microservice, TCP-based microservice, which is accepting this token payload. It will just check, okay, this token has been created with the same secret key, and it should be able to decode it. So token decode, if you see what it is there, it is created inside our auth service, inside controller. If you see decode token, so what it is doing is it is decoding it, and it is just checking, okay, this token is exist in the database, then checking the expiry and all, and sending it. That's it. Otherwise, what you can do is, I mean, there are many ways to verify the token: jwt.sign and jwt.verify. If you are not storing it in the database, you can just do a jwt.verify. Because JWT tokens, the prime objective is stateless. You create a token and you just verify it, and you can generate n number of tokens. They will be available till they expired, right? Okay, so this is just a demo, and here we are calling this. If the token info is there, then we are good. And then we can call this other TCP microservice, user service client.send get user by ID, because I got my user ID from the token payload. Okay, so what we will do is, first we will do the login. I got this token. I will add this token in the authorization, and then I can call this get users, and you can see I'm able to access this API, right? It's not magic. It's like, first you are sending this token to your token microservice. It is saying everything is good. Then you will be calling the user microservice, which is just doing there should be some query. Okay, user entity, which is just like a select query. Okay, give me this user based on this user ID. Okay, so this is like a plain and simple integration we have done through two TCP based microservice from the gateway service, which is exposing REST interface. Now same example, we can change the mechanism here. Instead of using TCP service, there can be another service which is using KAFKA, RabbitMQ or Redis. Then we will just have another service which is exposing, let's say this is domain APIs, domain service. Okay, And instead of TCP, what you are doing is, this is the client. There will be a client for this service. You will send a message like this is using Redis. This is using Redis as a transport. That means this service is a subscriber to the Redis host, and you have a Redis running somewhere, and this gateway, this client will send a message to the Redis host, I mean the Redis server, and then this domain services which is using the Redis transport will be listening to that server. It will receive that particular event, and you should be able to do particular actions. So this is like a publisher and subscriber. It's not like a request and reply. It's like fire and forget. You can send a particular action, and then based on that actions, this domain service will receive that event pattern, and then you can just act on that value or act on that and just do with that Redis data. Similarly, there can be a RabbitMQ Kafka. You send an event, because these are the message pattern. Event pattern is a send email, right? That is a fire and forget. So you will send it to the Kafka, and then there is a Kafka listener service using the Kafka as a transport, will listen to that and will get the payload. Okay, send this email to this email payload, email ID, and this is the email data. It will send it. So there will be a listener service where we will write that logic. Okay, so this is pretty much about the idea of TCP based microservices. Now what you can do is, in the same monorepo we can attach other services. I can just use this monorepo to extend this and add couple of more microservices using other transports, and we will see the demo. Thanks everyone. So this is just like a simple example. What I will do, I will push this code to the GitHub with the proper readme file. You can play around and see if it fits whatever you are building. It's good to learn something new out of the box instead of building just REST based APIs we are doing since a long time. Okay, thanks everyone. Thanks for watching.